Hello everyone, thanks for being here today to talk about data-centric AI. My name is Edouard. I'm the CTO and one of the co-founders of Kili Technology. And I'm with Andrea.
Yes, and I am Andrea, VP AI of Jellysmack.
So, if we are here today, in the same room, in this room, it's probably because on one side, we see that AI is having a tremendous impact in our lives. And at the same time, we start seeing some limits in the way we develop AI. Web giants, such as Google, Facebook, Amazon, Apple, all of them have placed huge bets on AI, but they also experienced huge fails. Okay. 2016, they bought on Twitter from Microsoft, became racist right after its launch. 2019, a leading computer vision system from Amazon recognized Super Bowl champions as criminals. April of last year, a computer vision system from Google recognized the very same object as a monocular in black in a white hands and a gun in black hands. September of last year, Facebook suggests to its user to continue watching video of primates, meaning of black men. And December of last year, Zillow, a real estate company, experienced a loss of $500 million because of a failed AI pricing algorithm. So what it means is that immature AI not only misses the business need and fails to deliver, but it also damages your brand, and it can even lead to bankruptcy. And in any case, it always backfires. Larry Page, one of the co-founders of Google, says, and I quote, "The risk of something seriously dangerous happening is in the 5 years time frame, 10 years at most." And Elon Musk, who is also one of the co-founders of OpenAI, says, "If you are not concerned about AI safety, you should be, because it's vastly more risky than North Korea." So of course, it's super difficult to say precisely where those fails came from. On one side, you had Tay, so the bot on Twitter, which was fed with human feedbacks, both positive and negative adversarial, without any filtering. And on the other side, you had Zestimate, the pricing algorithm from Zillow, which was probably far too complex, made of more than 1,000 models. And so what it means is that in the way the AI community developed AI those last few years was probably a bit too much focused on the algorithm and the model, and not enough on the data. Data-centric AI. So given the fact that AI is being developed at an exponential pace, and that risk seems to be inevitably tied up with AI, what we propose you today with Andrea is to answer to three very simple questions. So what is data-centric AI? Why is it so important for your industries? And how to accelerate this already happening trend? So what is data-centric AI? Data-centric AI is the practice of systematically engineering the data that is used to train AI systems. As said, the community, so AI is made of both code and data, and over the past few years, we focused a lot on the code, leading to always more complex models. Think GPT-3, 200 billion parameters, $12 million for a single training run, and last week, Palm from Google, 600 billion parameters. But my experience as an AI practitioner, and probably also your experience as practitioners, is that on our project, very often, it's not the model, the algorithm itself, but the data and its quality that makes or breaks an AI project. And data quality means two things. It means clean, having clean data, and having diverse enough data. Let's start with clean data. So an AI is garbage in, garbage out. So if you train it on inconsistent data, it's going to confuse the model and to decrease the performance. Let's take an example. Let's say we want to recognize forklifts and helmets on images. I ask my labelers to annotate the data. Here is what does the first one, so a big bounding box, and the two other ones, small bounding boxes. And the fact that they don't agree will decrease the performance, will impact the performance of my model. Three figures. A 10% decrease in the label accuracy means a 2 to 5% decrease in the model accuracy. And it also means having to double the dataset size to keep the same performance. And how to tackle this? You have to be able to measure this inconsistency, for instance, with the consensus, which is an inter-annotator agreement metric. Then to use a review workflow, so to choose between the different labels proposed by the different labelers, which ones are the right ones. And also to update the instructions of your labeling project with the edge cases, and to iterate. And those iterations are what we name data-centric AI. So data quality is about having clean data. It's also about having diverse enough data. Indeed, a model is only as good as the data it has been trained on. And a forklift can be used day or night, in the snow, in the rain, in the sun. And so for my model to perform well, I need to make sure that all those scenarios are in my dataset. Two figures. 40% of the data in dataset is redundant. And if you start labeling and training your model with the most interesting ones, you decrease the workload of labeling and model training by 30%. And so how to do this? You need to label some data, train a model, then test the model on the data to understand the failure modes, and then source and label more data to better cover the failure modes, and to iterate. And those iterations are, again, what we name data-centric AI. So data-centric AI is really about iterating on the quality of the data. Why is it so important for industries? I will give you two reasons. The first one is it means better performances. Indeed, our world is far from being perfect. It's full of human biases based on the social status, the gender, the age, and so on and so forth. For instance, if I ask a self-supervised machine learning model, this man works as he's going to tell me a lawyer or a doctor. If I ask the same question for a woman, it's going to tell me a nurse or a waitress. And so if we don't want our models to learn those biases, we need to filter and to curate the data. So the first reason is that, the first thing is that our world is biased, and we need to remove those biases. And the second thing is that it's also full of rare events. For instance, linguistic follows the zip flow. The zip law, meaning that, so this is this law, where you have the words on the x-axis and the frequency on the y-axis. And what it means is that most of the words are rare, not frequent, and then super hard to be learned by a neural network. And this is true not only for linguistic, but also, for instance, on the road. 40% of the data on the road is boring highway images. But you can still find some flying chairs on the road. And this is the reason why, at Tesla, for instance, they use their full fleet of camera-equipped vehicles to source those edge cases and to feed their autopilot system. And so because our world is biased and full of rare events, you need to curate the data. And data-centric AI is not a nice to have to do that. And it's really a must-have to get performing algorithms. The second reason, so the first reason why DCI is key is performing algorithms. The second one is that it reduces the development time. One of the key success factors of the software industry those last few years has been agile. It all started in the 2000s when Martin Fowler, a developer, met with 16 other developers, and they decided to change the way software was developed to make it more efficient and to get better quality software. And the way they changed it was to decided to make feature development and feature testing concurrent activities to force interactions between the software developers, the software testers, the project managers, and the customers, and the users. DCAI is agile for AI. So what it means is that it's possible to make data labeling, model training, and model testing concurrent activities to force more interactions between the machine learning engineer, the data quality engineer, the labeler, the subject matter experts, the project manager. And same as for agile in software, we can expect efficiency improvement up to 10x. So how to accelerate this already happening trend? The first thing is to set up a software 2.0 stack. Software 1.0, so traditional software, is about instructing a machine line by line with code. Software 2.0 is having a neural network figuring itself which rules are important to get a desired output. Software 2.0, AI, is king when the algorithm is difficult to explicit. Think, for instance, object recognition on images. And so if you think that software 2.0 is a bright padding, then you need, same as for software 1.0, traditional software, you need to set up a software 2.0 stack. Then the second thing is to find your IDE. Every developer in the world works in an IDE, which stands for Integrated Development Environment. It's like the Microsoft Word for a developer. It's a tool designed to type code, to type a lot of code, so very efficiently, and a lot of high-quality code. And the way it works, it's super interactive with syntax highlighting, linting, auto-completion, profiling, debugging, and so on and so forth. And so what you need is you need for Software 2.0 is also you need an ID. Coding in the Software 2.0 stack is about accumulating data, labeling it, cleaning it, visualizing it. And so you need a tool that allows you to accumulate data, label it, clean it, visualize it. That also helps you bubbling mislabeled images, assist you by seeding the labels with predictions, suggest useful images to be labeled, and so on and so forth. And anyway, this Software 2.0 stack and Software 2.0 paradigm is bright because it's more and more clear that AGI, artificial general intelligence, will be developed in this Software 2.0 stack. And the third thing that you need is a human in the loop, to set up a human in the loop culture. This AI, so it's a revolution. So it's not going to have no impact on your organization. It's about setting up, changing the way you develop AI to set up a human in the loop machine learning development process to force the machine learning engineers and the subject matter experts to work together. And so it's going to change the way you're organized, your development process, and maybe sometimes your business model. So what it means is that it's not trivial to do. It requires some efforts. But if you don't do it, you have to do it, because if you don't do it, you will get trapped. Think Zillow and all the fails. But if you do it, you will get better machine learning models with more safety, more transparency, more accuracy. And the way to do it is to start small, with the first DCI project to get momentum, then to create a multidisciplinary DCI team with subject matter experts and machine learning engineers, and then to provide broad DCI training. And what we do at Kili, is we create this IDE for Software 2.0, for AI. So a data training, AI training platform where you can code your AI through data. And it's fully compatible with the Software 2.0 stack. And it infuses, it helps to create a human in the loop culture in your organization. But in fact, the future is already here. And I will let Andrea tell you how it has been implemented at Jellysmack.
Thank you, Edouard. So let's talk about Jellysmack application of data-centric AI. Jellysmack is the biggest company in the creator economy, founded in 2016, and with a big fundraising with SoftBank last year, which gave us the status of unicorn multiple times. Jellysmack is 1,200 employees, and with 250 tech people and 50 in AI. We work with more than 600 creators. If we talk about our main product, is to helping creators to grow their audience. Grow means two things. Can mean extend their presence in all the platform, or in terms of globalization. We have the two use cases. So one is you have rushes or live streaming, and you want to go to Facebook or YouTube, or you already publish your video on YouTube and you want to extend your presence on all the platforms which monetize video, like Facebook, Instagram, Snapchat, etc. The data we have collected and we collect all the day is the unfair advantage of Jellysmack. We have three types of data. Public one, the data anyone can access on platform, like a view, comment, like follower count. Private data we retrieve from platform, but you don't have access to this data because you don't own the channel or the video. And proprietary is the data generated by Jellysmack, and no one outside of Jellysmack have access. Example of public data with views, like, comment, and follower. Example of private data, earnings, retention, A/B test results. And if we talk about the most important data we have, it's the proprietary data. So we have custom categories, custom tag, editing data, brand safety check, copy check caption, and we made all of this annotation on Kili, and we have all the custom metrics made by our algorithm. And to add just one more thing, all the data we have is cross-platform because we have a proprietary identifier to identify this video and this video in YouTube and this video on Facebook are the same video. It's the same video. Just to show you the globalization of our content. In 2020, 82% of the content Jellysmack made are from the US, and the rest essentially from France. In 2021, 68% from the US, but we have doubled the number of creators in US. And if I make a snapshot in February 2022, we have now 17 languages, 17 countries and 10 languages different. The data we have and the volume we collect are the unfair advantage of Jellysmack. To show you 3 examples. That's the views we made by quarter on Facebook. You see the growth. That's the number of rows in our database just for private data, plus 50% in 1 year. And the video we edit. We edit 7.6 thousand of video in February with a duration average of 8 minutes, which represents 100 million of frames. To resume, we have 2 types of data sources. The automatic ones made by the API from platform or made by our algorithm, or the manual or human in-the-loop data sources, like with all the annotation we made on Kili, or the business one, for example, editing on our tools. We collect a lot of data when you edit a video on one of our tools. Some example of editing work. Cut video into clip. We made this on Kili. Reframe, but it's not just cropping the image. It's really like composition work, as you see. And to give you one example I take often is on YouTube, men nipple are not considered to partial nudity, but on Facebook, yes. So if you want to take your video you have on YouTube with men nipple, if you want to push this video on Facebook, if you don't at least blur the nipple, your video will be demonetized, and if you have a lot of demonetized video, your channel will be demonetized. Now we have seen all the data we have, so okay, we need to have some feedback loop to train our model. The first one is the feedback loop we made on Kili with manual correction, with all the check, all the review by content strategist, and we use the 3 Kili tools, review, on HubSpot, and consensus to ensure quality even in adaptation process. And the second feedback loop is the final metrics, like earnings, because we are not a non-profit organization, and we fill all our model with the earnings, the views, the comments, the like we take on platform. If now we talk about multimodal self-supervised learning. First, about SSL, as Yann Lequin said, I quote, AI should learn by observing and predicting the world. So it means that you can have model without label and not pre-trained with label. And about multimodal learning, if you have a unified model architecture, you can train your model with multiple modalities. Now I will give you one example of project we have at each development stage. First, clip, that's in production for us. It's for channel categorization, and we use text and images from thumbnail for categorization. And we divide by 2 the false positive categorization in adding thumbnail in the categorization. In pre-production, we have AMA for image backbone pre-tuning to complete image, because when you have alcohol or ciggy in a video on YouTube and you want to push it on Facebook, you can't if you don't delete this type of object in the image. And in POC, we have VAT and AV Hubert for long to short content, for cut detection, for active speaker detection, and emotion recognition. One example of multitask learning. Imagine you have these 3 datasets. One with cut transition, one with clip selection, one with retention prediction, and the 2 first manual made in Kili. If we do a single task learning, you will need to take one dataset by dataset and one backbone by dataset, and you will have this type of scheme. As Andrea said, data quality will allow multiple models to do well, so the architecture can be shared. So let's take the same example. You have your 3 datasets. Now we have just one shared backbone, and you have this type of architecture. As a conclusion, for Jellysmack, be data-centric give us a categorization on our own category more than 95% of the video. Unsafe visual content is now blurred or replaced, so we divide by 10 the number of video demonetized, and we talk about $10,000 by month. And we have reached the performance of Adobe Premiere Pro for cut detection and edit task detection with a F1 score of 90%, and we are 3 times faster than Adobe. And in the future, we want to keep this impulsion by increasing data volume in terms of quality and diversity, as Edouard said, is very important, to improve robustness, fairness, and try to be the more we can multitask learning to leverage data efficiency and produce better and better algorithm and at lower computational works cost. Sorry.
So, as you understood, data-centric AI, so data centricity in AI, is really a revolution. And the question is not anymore if it's going to be impactful, because we know that it will. But the question is, are you going to adopt this revolution fast enough to turn it into an opportunity? If you want to get more about it, we have a booth right at the entrance of the event, nearby the ones of Facebook Meta. So feel free to come in and have a discussion. And if you have questions right now, happy to spend a few remaining minutes to answer them. Thank you.
Thank you very much, guys. Do we have any questions in the audience? I feel like there's some hesitation here. I have a question. Could you say a little more about the human in the loop? Who are those people and how do they do their job? It would be great to learn just a little bit more about how they're trained and what they're looking for. Sure.
So I will take an example. We work for a company named Vitalix, and they create a tool to help the blade cancer diagnosis. So to recognize cells who has a cancer. And the setup they have is on one side machine learning engineers, so building the models, and on the other side subject matter experts, so doctors, with the knowledge on how to recognize those cancer cells. And they use Kili as the platform to work together, to collaborate, with on one side user interfaces, so graphical user interfaces, where so the doctors see the images and label them. And on the side, you have an API where the machine engineers plug their models and they help them to label the data. And they collect the labels to retrain their models. And then you create a virtuous circle where so the subject matter expert, the doctors, label the data. The machine engineers get the labels, they retrain their model, and they help the labeling. And at every iteration, you already have a first model. And so you break the silos and you turn the machine learning model development in a process that is super agile.
That's great. Well, thank you very much for a fascinating talk, and be sure to check out these guys' booths. But then, thank you. Let's give it another round of applause.
Thank you.